Hey everyone, and welcome to The Explainer. Today, we're diving into a topic that, let's be honest, can sound pretty scary, but it's an absolute superpower for any developer. We're going to talk about turning coding chaos into total clarity with dynamic programming. So, what's the big deal with dynamic programming, anyway? What problem is it really trying to solve? Well, at its core, it's all about taming those wild problems, the ones that just seem to spiral out of control if you let them. I mean, come on, we've all been there, right? You write this beautiful, super clean, recursive function, you're so proud of it, you hit run, and crickets. Either it just hangs forever, or even worse, you get that dreaded Stack Overflow error. Poof, your elegant solution just imploded. So why does that even happen? Well, the main culprit here is just massive, repetitive work. Think about a simple recursive call for, say, the Fibonacci sequence. The number of calculations just blows up exponentially. That's that scary O of 2 to the n you hear about. And why? Because it's calculating the exact same values over and over and over again. It's this explosion of wasted effort that grinds our programs to a halt. And that is where dynamic programming swoops in to save the day. It's not some kind of magic trick. It's just a really smart, disciplined method. The core idea is honestly so simple, it's brilliant. If you've already figured out a small piece of the puzzle, why on earth would you figure it out again? You just store the answer and reuse it later. That's it. Decompose, reuse, and build. Okay, so that sounds great, but how do you know when you can even use this technique? Well, it turns out a problem is a perfect candidate for DP if it has two key properties. Think of them as two pillars that hold the whole thing up. Pillar number one is what we call overlapping subproblems. This is exactly what we were just talking about with that crazy Fibonacci tree. It just means the same little mini problems keep popping up again and again. DP is smart enough to spot these repeats and say, hey, let's just save this answer so we don't have to do it again. And pillar number two is optimal substructure. Now that sounds way fancier than it is. All it really means is that the best solution to the big problem is just a combination of the best solutions to its smaller parts. Think of it like this. If the shortest path from your home to the grocery store goes through a specific intersection, it must also be the shortest path from your home to that intersection. We can trust that our small, perfect answers will build up to one big, perfect answer. All right, so now we know what DP is and when to use it. Let's look at the two main ways people actually put it into practice. They kind of come at the problem from opposite directions, but they share that same core idea we've been talking about. So you've got two main flavors here. First, there's the top-down approach, which you'll often hear called memoization. This one usually feels more natural to a lot of people. You basically write your normal recursive solution, but you add a cache or a memo to store the results as you go. It only solves the subproblems it absolutely needs to. Then you've got the other flavor, bottom-up, or tabulation. This is the opposite. You start with the tiniest, simplest problems, solve them, and use those answers to build up to bigger and bigger problems, usually by filling out a table. It solves all the small problems first, just in case they're needed later. Okay, let's get to what I think is the most important part of this whole explainer. Look, the real key to getting good at DP isn't about memorizing a bunch of solutions. It's about having a system, a framework. And this framework we're about to go through is designed to turn what feels like a mysterious art into a repeatable step-by-step process. And here it is. It's a 6-step recipe. Step 1, clarify your goal. What are you actually trying to calculate? Step 2, define the state. This is just the information you need to describe a unique subproblem, like what row and column are we on? 3, find the recurrence relation. This is the heart of it. It's the formula that connects the problem to its subproblems. 4, identify your base cases, the simplest possible versions of the problem you already know the answer to. 5, figure out the order you need to solve things in. And finally, step 6, look for ways to optimize. That's it. Goal, state, recurrence, base cases, order, and optimize. Now, I know that can all sound a bit abstract, just a list of words, so let's make it super concrete. We're going to take this exact framework and apply it step by step to a classic, really intuitive problem. So here's the problem. Imagine you're on a grid. You start in the top left corner and you want to get to the bottom right corner. The catch? You can only move down or right.
The question is, how many different unique paths can you take to get there?
Just look at how the solution builds up in this table. It's so cool. The number of ways to get to any single square is just the number of ways to get to the square above it, plus the number of ways to get to the square to its left. See that? We are literally building our final answer, one cell at a time, using those smaller, optimal answers we already found.
Now, let's map this directly back to our framework. It fits perfectly. The state? That's just the number of ways to get to a specific cell, dp of RC. The recurrence? That's our simple formula. dp of the cell we're on equals dp of the cell above plus dp of the cell to the left. The base cases? Well, there's only one way to get to any cell in the first row or first column, so they're all ones. And the order? We just fill the grid, maybe row by row. See how that framework gives us the exact blueprint for the code?
So, the big question is, how do you take this framework and make it feel like second nature? Well, it really comes down to building the right mental habits and, you guessed it, a whole lot of practice. So here's a little tool for you, a mental checklist you can run through every single time. It's an acronym, GSRBOCO. It's our framework with a couple of extra letters. Before you even write a line of code, just ask yourself, what's the goal? What's the state? The recurrence, the base cases, the order, and then think about complexity. And finally, can I optimize this? Think of it as your pre-flight checklist for every DP problem. And really, that's the secret. It's not magic. It's just like any other complex skill, whether it's playing guitar or learning a new language. It's all about repetition. The more problems you tackle with a structured approach, the more you'll start to see the patterns, and the whole process will just become instinctive. So I want to leave you with a final thought. A challenge, really. Think about a problem that you've always found too hard, or a solution that was just way too slow. Now that you have this framework, that problem that seemed impossible, it might just be within your reach. So, what impossible problem are you going to solve first?